All right, lesson number 4, defining the Cisco One network. In this lesson, we're going to talk about the controller functions. We'll take a look at the different physical types of devices that can provide controller functionality, different types of physical deployment options with regard to the controller functionality. We'll take a look at the difference between the operating systems, like what is an AireOS controller, how does that operate, how does that function, how do we manage that? And then we'll take a quick look at product overview of the Meraki Cloud Managed Access Points and that whole product line. And then we'll take a look at the Cisco Aironet Premise Managed Access Points and those products in this lesson here. So it's all part of that Cisco One architecture. The controller itself provides lots of functionality in the network. It allows us to configure our access points with their VLANs, their IP addresses. We can manage the images for our access points, make sure that they're current and consistent with across the board. We can do our radio frequency management with RF space with regard to how they communicate to the APs, how the APs communicate to the clients, and so on. We obviously, of course, are going to have the ability to manage security. Are we going to use pre-shared keys? Are we going to use extensible authentication? We can even provide for DHCP addressing from the wireless LAN controller. There are some advanced features that the controller provides as well. AVC, that's like a visibility and control for applications, a security feature. SSO, single sign-on, profiling and policy classification. That can be done on a per user basis. Seamless roaming, if I'm moving from one wireless network to another, either roaming at layer 2 or roaming at layer 3. We can deploy it as a centralized architecture, or we can do converged access to control the wireless LAN based on those deployment models. And we talked about the difference between the converged access design and the centralized design. And we also support QoS, quality of service. So lots and lots of functions. The function of the wireless controller is really not limited to a box or an appliance on the network. It actually can be located in various components and different network locations, just like we do routing. Routing can exist in various points in the network as well. We can have wireless controller functionality in cloud-based controllers through the Meraki dashboard. We can have a dedicated hardware appliance that's running what we call iOS XE software. An example of that would be like a 5760 wireless LAN controller. Hey, throw in the chat window real quick if you happen to know what model you're using and what type of controller you're using, if you'd like. We can have dedicated hardware appliances that are running the AireOS, like the 8510, the 5508, the 2504. Those are the most common controllers that we see with businesses today. You can have virtual machines that actually run the AireOS virtually using the virtual wireless LAN controller on a UCS platform. Or you can run it using SRE 7010 or 910 or even the UCS E-Series server, or you can run it in an ISR. The ISR G2 routers can have UCS blades in them as well. You can run it as a module and a switch running AireOS, like the WISM, the Wireless Services Module, and 6500, or you can run it integrated into the actual iOS XE software on, say, a 3850 or a 3650 switch, or even a Cisco Catalyst 4500 supervisor engine. That also supports the integrated, the converged access model. So lots and lots of different options. Let's see, yeah, there we go. I was off on one slide. And this kind of visualize gives you a visual representation of what that looks like. These are the on-premise virtual wireless LAN controllers. They can run on general hardware under a standard VM environment. Really great for small to mid-sized deployments, especially if you have a distributed branch environment. We can support, and again, this information is based on when this document was published. So I don't always go back and verify all this information on Cisco.com, but you can pretty much assume these are minimum values because some of the newer iOS and some of the newer platforms will actually support more than what I'm describing here. In a virtual wireless LAN controller, you can have up to 200 access points, support up to 3,000 clients, and have up to 200 branch offices. And it's going to co-reside on a server platform in your virtualized environment, which can also include ICE, Prime Infrastructure, your mobility services engine, and so on. Connectivity with the Cisco FlexConnect solution works very well in this. We'll talk more about that in detail a little bit later on. Independent and mutually exclusive instances, right? Because we can put UCS servers anywhere, we can have ISRG2 routers anywhere, and we can have E-Series blades or a service engine in these routers anywhere we would like. So that allows multiple virtual controllers to manage different campuses or different sites. These can be deployed with high availability, failover protection, migration, and so on. Cloud-based controller, like I said, the Meraki provides the cloud-based solution. Gives you obviously an interface to provide centralized management and monitoring, supports BYOD components, location analytics, application visibility and control. That's the AVC function that I've been talking about. High capacity, 802.11ac functionality, security radios that allow us to identify attacks and vulnerabilities. So they're not doing client provisioning, but they're providing security services. I'm not going to spend a whole lot of time on this part of the slide deck because, again, this information changes pretty, I wouldn't say constantly, but pretty significantly over time. So some of this information might be out of date. The physical deployment of a controller depends on how you've decided what model you're going to use, right? Are you going to use iOS XE or are you going to use AireOS operating system to provide that functionality? Converged deployments would include iOS XE. So any deployment that utilizes iOS XE is classified as the converged deployment. That would be implementing wireless functionality on a 5760, 3850 switches, 3650 switches, or the 4500 Supervisor 80 engine. Centralized is anything that's going to use AireOS typically. It could be iOS XE for the 5760. That's available for the centralized deployment as well. And then FlexConnect is only supported with AireOS. iOS XE doesn't support the FlexConnect mode. Capacities for both iOS XE and AireOS controllers are going to differ based on the software release, the licensing, the number of APs, the throughput, etc. So like I said, you want to make sure that you check Cisco.com to see what the latest information is if you're looking at some of these different platforms. Do any of these platforms look familiar to you guys? I'm curious what kind of switching hardware you guys are using, what kind of controllers you're using. If you have an idea, if you do, send a chat message, let me know. And we can kind of focus on some of those platforms. I will say this though, when you're dealing with iOS XE or AireOS, it doesn't really matter the platform because the configuration and the interface is identical. Whether you're configuring a 2504 or 5508, the functionality looks exactly the same. If we're working with unified access in iOS XE, which is going to include architecture for routers, switches, appliances, and so on, it's going to be any wireless service that's provided by iOS, but it's going to add functionality and benefits of different components, right? You've got your switching, you've got your routing built in, but you're also gaining access to the combination of the wireless piece as well. Cisco combines this Catalyst switch functionality with the wireless controller functionality into a single converged platform. One of the downsides to this approach, and we've seen this with clients that have actually implemented this approach, is that in order for a 3850 or whatever to act as a controller for a particular access point, that access point has to be physically attached to that switch. So you would have disparate controllers throughout your enterprise if you had access points kind of dispersed throughout your enterprise. which takes you away from the centralized approach, but that's why this is not called a centralized approach. It's called a converged approach for that reason. iOS XE retains the exact same look and feel as the iOS, the Internetwork operating system that you're used to using, but it also provides enhanced features and functionality for the wireless piece. There's a single daemon within the Linux operating system that provides that functionality. Any additional system functions, they're going to run as a separate process in the host OS environment. So we're not actually utilizing some of the same processes that we're using for our switching environment. If you are running iOS and other applications as separate processes, it enables load balancing. The multi-core CPU allows each process to use different cores if necessary, and then we can support multiple threads in that multi-core CPU environment. All right, so iOS XE permits the integration of non-iOS applications. We have a standard Linux-based environment for hosting those applications. You see that listed here on the diagram, by the way, and that extends those iOS functions into those peripheral applications through application programming interfaces. You get CLI access, you get XML access, you get SNMP access, HTTP-based management, and so on. All right. What products include this? Well, there's a few, and again, probably more than what we see here because of the date of this material. But the 3850 switch is an enterprise class switch that's a stackable switch. It's got power over Ethernet, supports up to 2,000 clients per stack, runs CAP/WAP that gets terminated in hardware. CAP/WAP we'll talk about a little bit later on, but that is our encapsulation protocol that allows us to encapsulate the traffic from the access points to the controller. Up to 480 gigabits a second of stacking bandwidth. You guys have probably dealt with or at least seen stackable switches in the past. It kind of started mainstream, at least, with the 3750s and has kind of progressed from there. But in the end, the wireless controller piece is what we're concerned about when we're integrating that controller piece into the stack. Up to 40 gigs of wireless capacity per switch, and up to 50 APs and 2,000 wireless clients in each switching entity. That would be a switch within the stack or the stack itself. The stack-wise communication, which is that proprietary physical layer cable ring that you attach on the back of the switch stack, provides up to 480 gigabits a second of throughput, which gives a lot of power in passing data from one switch to another within the stack. You have some optional uplink modules as well, 4 times gigabit Ethernet or 2 times 10 gig Ethernet, depending on the model itself. Full AT support, PoE. There's a couple of different variants of power over Ethernet, but it's PoE Plus in this case, which provides up to 30 watts of power per port. And we have support for IPv4 and IPv6, QoS, enhanced security features, and so on. All right. That's the 3850 model. Another model, which is actually what we have in our lab environment for converged access, is the 3650 switch. It's an enterprise class standalone stackable access layer switch that provides a lot of the same functionality, right? Up to 40 gigs of wireless capacity per switch, 25 access points, 1,000 clients, so not as highly scalable as the 3850, and so on. Lots of different uplinks, 4 by gig, 2 by 10 gig, and some models 4 by 10 gig as well. The stack itself doesn't go up to 480 gigabits a second, but it does do up to 160 gigabits a second of stack throughput. and redundant power supplies, modular fans. Again, 802.3 AT power over Ethernet support, PoE plus, 30 watts of power, IPv4 and IPv6, and so on. If you want to look at the 4500E, which is your chassis-based switch, that's going to have the SOUP 8E. That's going to bring in convergence as well. It delivers about 928 gigabits a second of bandwidth, up to 20 gig wireless throughput, 50 access points, 2,000 wireless clients on a single system, and so on. If you want to deploy this in redundant fashion, you would simply have another 4500E chassis, and you would use things like non-stop forwarding and stateful switchover, multi-VRF components. Also support for PoE plus on the line cards, depending on what line card you put in the switch. In this case, this is just a supervisor engine. If you want to take a look at an appliance version, the appliance model, this is a 5760 wireless LAN controller. It's designed for primarily 802.11ac networks. Okay, you'll notice that from the uplinks themselves. The 6x1 or 6x10 gig SFP plus uplinks with link aggregation. That's going to be required if you're pushing a lot of AC clients through the device. Wire speed up to 60 gigs of throughput, because you can see we have 2, 4, 6 different ports on the front here. Each one of these offers either 1 gig functionality or 10 gig functionality. Up to 1,000 access points per controller. 12,000 clients per controller spread across those 1,000 access points. NetFlow version 9. What else? Cisco Clean Air, Client Link 3, stateful switchover if I want to run redundancy, AP stateful switchover. We'll talk about that later on. Application visibility with AVC, and many, many other features. All right. In the AireOS space, wireless controllers exist as well. AireOS wireless controllers support a few more features, like Flex Connect. They can be deployed as a centralized deployment, or they can be deployed, we talked about this before, as a virtual wireless LAN controller. Mesh, Office Extend, we'll talk about some of these different deployment models when it comes to AireOS a little bit later on. Some of the platforms do link aggregation, some of them support guest anchoring, but not every model. And we'll just talk about, I guess, really the main difference between the appliance-based AireOS wireless controllers versus the virtual controllers. And that's what we'll see in the next few slides here. This is the kind of controller that I have at my home office here. 2504 wireless controller. Packs a little punch, right? Runs the same software, same AireOS software that you would see in a larger enterprise class controller. It just doesn't support as much throughput or as many clients, right? Up to 75 access points, up to 1,000 clients. One has 4 1 gig Ethernet ports. 2 of them provide PoE, as you can see on the diagram. Wired network speed, non-blocking performance for 802.11n and 802.11ac. You do have to do some link aggregation. Supports up to 1 gig of throughput. Console port is obviously RJ45. You can see that there. Does support guest anchoring functionality. So that concept where we had our primary wireless LAN controller and we would put a guest anchor controller in the DMZ just to pass that guest traffic, this little guy will actually support that functionality. And it does support link aggregation. Okay. I am guessing, although I'm not 100% sure, I'm guessing that this is probably the controller or a variation of this particular one that you guys might be running in your enterprise. The 5500 series controller, up to 500 access points, up to 7,000 clients, 8 uplinks if you're looking at the 5508. They're gig. They can either, because they're SFP plus ports, they can either be copper or fiber. You can do short haul or long haul. There is a utility port and a service port as well. You can see those on the left side. Supports guest anchor access as well. And also supports link aggregation. All right. If you were to log into a browser and look at the 5508 interface, it would look essentially the same as your 2504 interface as well. Now, up until recently, this guy here was really the monster controller that Cisco had available. Now, they've gone since to higher versions of this, and we can support even larger deployments, but this guy is pretty powerful, right? 7500 series controller, up to 6,000 branch offices, right? And meaning that you can have up to 100 APs per branch location. Supports 6,000 access points, up to 64,000 clients. Can be deployed as Flex Connect. Has 2 10 gig Ethernet ports as well. Provides 1 gig of throughput. It's got a service port and it supports link aggregation as well. All right. 8500 series controller. Looks very similar to the 7500 series controller. 6,000 access points, 64,000 clients, up to 100 APs per branch location, 2 10 gig interfaces, service port, redundant power supply, does support guest anchor functionality and link aggregation as well. Okay. I think these numbers are a little bit skewed because I do think that the numbers have gone up significantly since 2014 and 2015. But Cisco.com, if you just go to Cisco.com and search on wireless LAN controllers, you can see the latest information. All right. Next one is the WISM. WISM stands for the Wireless Service Module, or Integrated Wireless Service Module. This is used for the 6500 series switches. Those are those chassis-based switches that provide a whole bunch of different functions and features. Up to 1,000 access points here, 15,000 clients, 20 gigs of throughput, has a redundant port, has a service port. Redundancy port is used for failover, of course. Has a console port, supports the guest anchor functionality as well. We'll switch gears a little bit here, take a look at some of the cloud-based solutions, the Meraki solutions. The MR series APs are part of that cloud-based solution, so the MR32, MR34, those are going to be your AC compatible devices. They're going to deliver you the higher throughput with the different spatial streams and the different antennas. Pretty much all the same functionality that you would expect to get from any type of wireless access point, right? Security, guest access. We can use WIDS and WIPS, that's the intrusion detection and intrusion prevention systems. We can do RF optimization, spectrum analysis, beamforming, MRC, role-based administration, email and text messaging alerts, subscription licenses are used in this case to operate these particular models. So we'll just run through a quick list of some of these. The bullet points are here, MR18. I don't really need to read all of these. I guess it's pretty easy to understand. This particular platform has integrated omnidirectional antennas, 3 dBi at 2.4 gigahertz and 5 dBi at 5 gigahertz. So you don't see that on the slide here. But it is an 802.11an radio at 5 gigahertz and at 2.4 gigahertz BGNN up to 300 megabits per second. Okay, does do similar to what Clean Air is with wireless security and RF analytics. You can do a concurrent operation of all 3 radios, and it only draws, and this is actually a really important concept, about 9 watts of power, maybe closer to 10 watts of power. So it can run in most PoE environments, especially with PoE+. Up to 2 spatial streams, beamforming, to 20 megahertz wide channels or 40 megahertz wide channels with this particular access point. Everything pretty much applies to the MR26 as well. It's a 3x3, 3 spatial streams. Again, integrated antennas, 3 dBi at 2.4 gigahertz and 5 dBi at 5 gigahertz, up to 450 megs of throughput on this guy. Same thing, wireless security analysis, RF analytics, concurrent operation of all 3 radios if you'd like, because it is a 3x3. Remember what the 3x3 meant? I had 3 antennas that were used for transmitting and 3 antennas that were used for receiving. And we can operate all those antennas at the same time. The next Meraki is the MR32. This is a 2x2. It only has 2 spatial streams. Also integrated antennas, 5 dBi at 2.4 gigahertz and 5.5 dBi, I think, at 5 gigahertz. It does AC compatibility, 20 megahertz, 40 megahertz, and 80 megahertz wide channels. Maximum power draw of only about 14 watts, so that's good as well. Works in pre-standard or PoE environments. You don't need the PoE plus component. There is a dedicated 4th radio in this. That's for BLE functionality, the Bluetooth radio. Any Bluetooth device that's within range of the AP, which allows you to add things like location-aware applications and stuff like that. All right, and you can run all 4 radios at the same time in this platform as well. The MR34 has integrated omnidirectional antennas. I'm not sure what the power level is. 20 megahertz, 40 megahertz, 80 megahertz channels for 802.11 AC anyway. 18 watts max. That's going to be your 802.3 AT standard, or 13.87 watts max if you're running the 802.3 AF power standard. Up to 975 megabits a second of throughput, and AN and AC functionality and BGN functionality. There are some outdoor access points available as well. The MR66, the MR72. Everything here is pretty self-explanatory. Not a whole lot to say about that. On the Cisco side, we have lots and lots of access points that are available as well. 600 series, typically used for remote workers. The 700W is designed for spaces like hospitality, university residence halls, stuff like that. 1700 series for small or mid-sized businesses. 2700 series for schools and warehouses, and then the 3700 for large offices and mid-sized and large warehouses. I happen to have the 3700s in my house because I like the clean air capabilities. Most of these access points have that clean air functionality. There's actually a video on our YouTube channel that talks all about, it's from Cisco TV, talks all about the clean air technology and what that does and why it's so special. I highly recommend that you go out and check that out. Okay. All right. And of course, go to Cisco.com because, again, they're coming out with new technology all the time. Cisco Clean Air is a technology that's used for kind of monitoring the spectrum. And we're not talking about monitoring 802.11. We're talking about monitoring the actual radio frequency spectrum. So it's kind of acting like a spectrum analyzer. The purpose is to obviously provide self-healing capabilities, self-optimization, avoid RF interference and so on. Client Link 3.0 is provided as well. Band select to improve 5 gigahertz client connections over a mixed client environment is included. Video stream, which uses multicast to improve your different multimedia applications. And obviously these are all controller-based access points, so infrastructure type access points. There's no cloud solution for these presently, although I'm not sure if Cisco has any inclination of integrating those cloud solutions into these platforms. All right. If you see a model, yeah, Mike, go ahead.
Question for you. We have the 3700 series, and the rigid antennas, those are the rubber duck, the ones that don't swivel?
Yes.
So if they're equipped with those, you should probably be ceiling mounting them, correct? Not wall mounting?
Absolutely correct. Yes.
Okay.
Absolutely, because you're going to get that donut shape from those omnidirectional antennas. So if you're mounting them vertically, you're getting great coverage above the access point on the ceiling and on the floor, but you're not and you could be getting some bleed over, you know.
Yeah, it's working, but based on what you've been talking about the last couple of days, obviously it is not optimal.
It is not optimal. That is correct. Yeah. Now, actually, that kind of goes to what I was about to say, which is if you buy a model like this, if you see a little I next to it, like a 3700i, that's going to indicate that that model has internal antennas. An E indicates that you have external antennas. Just something to keep in mind. Pretty obvious, but okay. So we'll break down each one of these platforms. Like I said, the Cisco AiroNet 600 series is what we call an Office Extend access point. It provides security, dual band functionality, 802.11n access. It's 2.4 gigahertz, 5 gigahertz. Both radios can operate concurrently. 2x3 with 2 spatial streams. 20 megahertz and 40 megahertz wide channels for the N functionality. So that means you're going to get a data rate of about 300 megabits per second. It's got a gig twisted pair Ethernet WAN port, 1 management console port, and then 4 10-100 1000 auto sensing ports. You can see the icons here. So if you want to actually connect physical clients, so it acts as a workgroup bridge as well. So it's got a 3 dBi 2.4 gig antenna and a 4 dBi 5 gig antenna built into it. All right. Well, it's a cool little access point, I think. The 700 series offers the same kind of connectivity, 2.4 and 5 gigahertz. Both radios can operate concurrently. 2x2 with 2 spatial streams, 20 megahertz wide and 40 megahertz wide channel, 802.11n, up to 300 megabits per second. 1 console port and 802.3 AF power requirements. The 700, which you see on the top there, has a 2.4 gig 3 dBi antenna and a 5 gig 4 dBi antenna. And the bottom one that you see there also incorporates 4 10-100 1000 Ethernet ports for wired connectivity as well. All right. This is a very, very common access point. Very common access point. 1700 series, 2.4 and 5 gigahertz. Again, both antennas can operate concurrently. 3x3 MIMO with 2 spatial streams, 20 and 40 megahertz channels, 802.11n. Goes 80 megahertz channels for 802.11 AC, so we're not going to get wave 2 in there, but we support 802.11 AC wave 1. Data rates up to 867 megabits per second. This is the first one that we've seen now that supports the Clean Air functionality. It is the Clean Air Express version, but it does support Clean Air. 2 10-100 1000 auto sensing ports. Now, the reason it has two is because of that AC functionality. You're going to want to be able to get that throughput that you need by actually aggregating those ports together. One management console port, 802.3 AT power, which is PoE+, and at 2.4 gig, you're going to get a 4 dBi antenna. At 5 gig, you're going to get a 4 dBi antenna as well. Then you move into the 2700 series, 2.4 and 5 gigahertz, 3x4 MIMO with 3 spatial streams, 20 and 40 megahertz and 80 megahertz, but data rates in this case up to 1.3 gigabits per second. Full clean air capability, client link capability, BYOD functionality, 2 10100 1000 ports, PoE+, again, 2.4 gig, 4 dBi antenna, and a little bit more powerful on the 5 gig side with a 6 dBi antenna on the 5 gig side. And then you get into the main enterprise class antennas, access points, excuse me. The 3700 series has full support for 802.11ac Wave 2. So you're going to get both radios, 4x4 with 3 spatial streams, 20 and 40 megahertz channels, 80 megahertz channels on 802.11ac, clean air, client link, kind of the same functionality. 2.4 and 5 gigahertz is going to operate a 4 dBi gain antenna. All right. Now, what's interesting is that the 3700 also supports add-on modules so that you can add functionality in the future. And so if you want to add things like clean air technology for spectrum intelligence, WIPS scanning for threat detection, that's wireless intrusion prevention, rogue detection, location, context-aware identification services, radio resource management to constantly analyze the quality of the air, and so on, you can utilize those add-on modules. Those are the wireless service modules that you can add on to the 3700. For some of these external access points, you do have, they could have picked some better diagrams for this slide. Wow. You do have options with these external antennas. So one of the options, Mike, is you could potentially replace the antennas on your access point. It might be easier to just remount them, but both the 27 and the 3700 series models support external. They do have external antenna options. As far as the 2700 goes, you can do black, gray, or white, dual band dipole antennas. For the 2.4 gigahertz spectrum, you can do 2 dBi. For the 5 gigahertz spectrum, you can do 4 dBi. That's one of the options. I can't remember the model number for the antenna itself. They have some other options too. The ones that you probably have are the ones that are dual band omnidirectional ceiling mount. They have ceiling mount, they have wall mount, and then they have one that doesn't have any specification, which means that it can be mounted anywhere. If you look at the actual antenna number, like the model number of the antenna, you'll see a C or an M, and that will indicate whether it's supposed to be a wall mount or a ceiling mount. If it has an X, I believe that's the one that has the swivel and rotate antennas that you can change. There is a patch antenna that you can get as well, so that might be an option in your case, is to change out the dipole antennas with a patch antenna. But as far as the 3700 goes, you've got dual band outdoor stadium antennas, 13 dBi. And as I mentioned before, And as it says here on the diagram, the gold ring around the antenna indicates that it's actually a dual band antenna. Okay. Outdoor access points. 1530, designed for obviously indoor, outdoor, not ruggedized, but it is water resistant and can be installed without an enclosure. But 2.4 and 5 gigahertz. The 1530i does 3x3 at 2.4 gigahertz and 3 spatial streams. And at 5 gigahertz, it does 2x3 with 2 spatial streams. The 1530E, which is more of a ruggedized version, 2x2 MIMO with 2 spatial streams at 2.4 gigahertz, 20 megahertz wide only channels on 2.4 gigahertz, and up to 40 megahertz wide on 5 gigahertz. So that's your 802.11n. The 1550, definitely designed for outdoor access, typically going to be used in a mesh environment. You can kind of see the antenna bubbles on there. Those represent the antennas themselves, but 2x3 with 2 spatial streams, 20 and 40 megahertz wide channels, 802.11n. Again, designed primarily for outdoor mesh environments. All right. 1570 as well. 1570 is a little bit bigger, does 4x4 MIMO and 3 spatial streams, 20 and 40 megahertz wide channels, and 80 megahertz wide channels. So I guess as we kind of go through all these different models and we look at all these different access points, that's the end of our lesson here. But one of the things I want to point out is, had you been looking at these specifications 3 days ago, before we started this class, maybe you might not have known what they meant by 20 megahertz wide or 40 megahertz wide or spatial streams or 2x3 and so on. So hopefully now you see this stuff, you kind of pick it up a little bit and you understand what it is that we're talking about. So in summary, the controller obviously can be a dedicated appliance, it can be a virtual machine, it can be integrated within the switches, it can be inserted into a virtual machine on a router. That's the virtual wireless LAN controller. You've got the 3850s and the 3650s that provide converged access with iOS XE. The 2504, the 5508, the Flex 7500, 8500, the WISM, those are your AireOS controllers, which is what pretty much everything is going to these days. Can be cloud-based like the Meraki, and we take a look at all of the cloud-managed solutions. And then in this lesson, we also kind of took a look at all the different access point models and what kind of radios they had and so on. Bottom line, I keep saying this, I'll say it one more time before we wrap up this chapter. If you want to see what the latest and greatest is, always go to Cisco.com, because as a Cisco partner, we are, my company as a Cisco partner, and we do a lot of integration. We do see these things are constantly changing. So always go to Cisco.com and check it out. So we'll wrap up this lesson in the we'll wrap up this lesson. In the next lesson, we're going to talk about our mobility architecture concepts. We'll take a look at the different types of mobility functionality that we see in the wireless networks. It's a good chapter. It's something that is very important when it comes to deploying wireless networks in modern enterprises today.